When you see a sinusoidal regression on a diploma, I hope that you're excited about it. So we're going to go stat. We're going to go to y equals, make sure it was cleared, right? And we go to stat, we go to edit, and we clear our lists. We don't delete them. But if we delete them, you can always just reset your calculator. It will come back. It's not the end of the world. Okay. So we go 0, enter, 9.25, enter, 18.5, enter, 27.75, enter, 37, 46.25, 55.5, 64.75, and 74. And then 49, 295, 541, 295, 49, 295, oopsies, 49, 295, 541, 295, 49. Just so you know, sinusoidal regressions need at least 5 coordinates or they can't happen. Okay? So, a sinusoidal regression, everyone paying attention? Sinusoidal graphs are like heights over time. Ooh, grab a marker. So if I had a graph that was like this in real life time, okay? So this is my graph. This could be like, this is not representing this. I'm just showing you what everyone paying attention because it's something new. So if I had like minutes down here, let's say, I had 0, then I had 10, then I had 20. It's nothing to do with this question. Don't try and link them. 30. And then this was like 5 and 10. And this was height in meters. Okay, paying attention? What they could do is they could say, oh, if I'm going around in a circle, everyone watching, because this is a circle or a pendulum over time. This is sinusoidal graphs can be represented by anything where there's a min and there's a maximum, and it occurs at the same time. Like the max to the min might be 10 minutes apart, and the min to the max would be 10 minutes apart, 10 minutes apart, 10 minutes. Like they have to actually be the same time apart and same height. So it would be like maximum to a minimum, then back up to the max, and back to the min, then back to the max, and back to the min. And the time being the same matters because it has to be the same shape, correct, over time? If it's sped up, you'd get this, and then you'd get this, and then you get this, and then that wouldn't be a sinusoidal graph anymore. It has to be exactly the same curve, up, down, up, down. If I sped up, it would do this, and then slow down, it would do this, right? So it needs to be that same max, min, max, min, max, min occurring at the same distance, not speeding up, okay? So if I had a circle like this, let's say, and this was 0, and this happened 0 at 0 minutes, I don't write this, we're just taking in what a sinusoidal graph is, and this was 0 meters, then I would have this dot here, correct? Then, if at this spot here, I was at 10 minutes and 5 meters, it would be here. Then say my maximum was at 20 minutes and 10 meters, then it would be here. And then this would be 30 minutes and 5 meters. It would be here. And then back down to 0 at 40 minutes, right? Like same time. And I could just keep going. Then it would be 50 minutes. Then it would be 60 minutes. And I would go around. Is everyone paying attention? So we're going to get a graph that looks like this. And it curves up here, and then it comes down like this. And if I kept going, it would just continually do that. And pretend that this looks the exact same. Mine obviously isn't sketched perfectly, but it should be same amount height, you know what I mean? Mm-hmm. Now if I sped up, it would do this. Same height, same minimum, same maximum, but now is the graph actually the same? No. So not only do I have to have the same min and max to make a sinusoidal, I have to have the same time that it takes for that to happen, to get to a min and a max. So this one to get to the max takes 20 minutes. So every time to get from a min to a max, it's going to have to be 20 minutes, or this isn't a sinusoidal function. Okay? All right. So we typed this all in, this actual thing, and it says, in 2011, the Singapore Flyer was the largest Ferris wheel in the world. The table below gives the height of a rider from the ground at different times. So this is the Singapore Flyer. We put that in. Jordy got on the Singapore Flyer at noon. So he got on it at noon and rode it for 4 consecutive rotations. Okay? So if he got on at the bottom, that would be 1 rotation, correct? Go back down to the bottom. 1, 2, 3, 4. We agree? Go back down to that minimum height. So that's 1 rotation, 2, 3, 4. We agree? Now here it says determine a sinusoidal regression. So it tells us that, correct? And anything in the shape of a circle or a pendulum will follow sinusoidal. Why would a pendulum do that? Well, it's going to go from a max to a min to a max to a min to a max to a min to a max to a min at the same amount. If the pendulum speeds up or slows down, does that work? No, it has to be like a consistent pendulum. So anytime I go from a max to a min and keep that same amount of time to get back to the max, you can follow a sinusoidal graph. This distance over time graph. Okay? So you guys all put in your calculators already. We went stat, we calculated it, and if you arrow up, you can get there faster. It's C. Now for our diploma, we talked about this. We can have 4, 5, 6, 9, 0, and C. Those are the only options. If I pick anything else, am I going to do well on the diploma? No. Those are the only ones you should be picking. 4, 5, 6, 9, 0, C. So we can calculate it. It gives us our equation. And then we have to go bars, statistics, over to equation, enter. Our window is 0 to x max. This one's 74. I'm going to do, let's say, 150. And then I'll see if it gives me way more than 4 or less, right? Okay. And I'm going to make these go up by 10. Then the y minimum is 0. Y maximum looks like 541. So I'm going to go 550. Make it go up by 10. Now the key thing is your calculator needs to be in radian mode, so go check it. Make sure the mode you're in is radians. Your calculator will reset itself. Everyone's paying attention to me, every single person. Because some of them might try and put your calculator back into degree in the diploma. And you say, no. Your calculator always has to be in radians. If your calculator goes into degree at any point in time, every sinusoidal question will be wrong. So for 20-1, your calculator always needs to be in degrees. So the teacher stands in front of the room and they say, okay, everyone reset your calculators. Now, everyone, make sure that you put the mode back in degrees, right? That's what every teacher says, because you need to have it in degrees for trig. So if someone tries to turn your calculator into degree mode, say no and leave it in radians. The moment your calculator is reset, it is perfect for you to use. Do not change anything. That's the greatest part of 30-2. 30-1, they have to float between radians and degrees. 20-1 has to be in degrees. 30-2 has to be in radians, which is what it resets itself into. Yeah.
What do the modes even do?
Radian is a different measurement. So for example, degrees, 180 degrees is pi radians. They're the same measurement, just like if I said 2.5 centimeters is 1 inch. They're the exact same length, but they're in different units. Radians and degrees are the exact same angle in different units. So radians only make sense for word problems because you can't say, oh, I go around the circle in 360 degrees, right? You can't say, oh, I go around the circle in 294 degrees. That makes no sense. But radians aren't in degrees, they're in just units. So you can go around in 2 pi radians. You can go around in pi radians. You can go around in 12.7 seconds. So if you don't want to say I went around it, if I say that I went around this one in particular, this top one, I went around it in 40 minutes, it can't be degrees because that would be 40 degrees and you didn't go around a circle in 40 degrees. Yeah. So the only way it makes sense for us is because we do everything in word problem situations, has to be in radians. So radians is just another way of saying a degree length, just in radians, just like inches and centimeters, millimeters and centimeters, meters and feet, right? All right. So, determine a sinusoidal regression to the above data. Round your values to the nearest hundredth where necessary. So if I press graph, my guess, that was a sheer guess, just so you know when I went with 150. You're welcome. It gave us 4. Okay, I just doubled what the table gave me because it looked like it may have done two revolutions. So I have 4. But I need the regression to the nearest hundredth where possible. So I go stat, calc again, and I bring back up my sinusoidal regression. So We're going to go y equals, to nearest hundredth is only this one and this one that needs to happen. The other ones are solid. So we're going to go y equals a. A is 246. So I'm going to go y equals 246. And then I fill it in just how it says. Then it says the word sine. This is sine, like a sine costan. That's what this is. It's a trig graph. So we go a sine. We don't need the time symbol. So we'll go a. So 246 sine. Then it says open bracket b. So I'm going to go open bracket b. B is 0.17 to the nearest hundredth. So 0.17. Then it says x. So I put an x. Then it says plus c. Now if c is negative, if I plus a negative, it's just negative, correct? So I could go plus negative 1.57, or I can just go minus 1.57. Then, come on, and it shows a closed bracket plus d. So I'm going to do a closed bracket plus 295. Now here it says Jordy's friend Yale was in a building directly across from the Singapore Flyer at a height of 400 feet. So did I give you time, which is x, or height, which is y? I gave you y. Okay, let's go back to that. Jordy's friend Yale was in a building directly across from the Singapore Flyer at a height of 400 feet. So y equals 400 feet. When was the second time Jordy was at that level? So where's the only place I can input y's? Into y equals into y2, correct? So I'm going to go to my y2, and I'm going to put in 400. And I need the second time, because it says that, right? So I'm going to do second trace 5, find the intersection, and I go to the second time, so this one, right? So second trace 5. Arrow up if you want to get on that flat line. And now I need to get close to that second time. Enter, enter, enter. And it says the second time, it doesn't give us a rounding rule, it will on the diploma. So I'm going to say to the nearest tenth, what would it be? 25.2 what? Minutes, because it's time. And then I'm done, and I move on to the next question, and Mrs. Lepp cries. Why is she crying? No sentence. So, when was the second time Jordy was level with Yale? You can say at 25.2 minutes. Is the second time. Jordy level. Yeah. Then the next one says, at what height was Jordy at when the time was 96 minutes? So now I gave you 96 minutes. Did I give you X or did I give you Y? Go to our table. I gave you X because X is time in minutes and Y is height in feet. So I gave you X. X equals 96. Now, if my calculator errors, what's the problem? We've discussed this numerous times. Your window's not big enough. So if your X max doesn't contain 96, you can't find it. Okay? So we're going to go, I'm going to clear out my Y2. I'm going to go second trace value, and then 96. Go around to the nearest 10th again, 498.8. 0.8 what? Feet. And then I'm done? No, we need a sentence. So, Jordy was at 498.8. Well, that is not 498. 498.8 feet at 96 minutes. Now it says, at what time did Jordy get off the ride? The fourth time the height is what? Yeah, and what was the minimum? Look on your table. What's the minimum? You guys getting on a Ferris wheel. Pardon? 49. Looks like 49 feet, right? And how do we know that that's the minimum? Well, I press graph. Look. So can I not find this minimum? How would I find this minimum, guys? You know what this is. What is this? Your y-intercept. How do I find a y-intercept? Yeah, so second trace value 0, which is 49. It's also on our table, correct? Do you see that? So, at what time did he get off the ride? We know the minimum is 49 feet. So we need when y2 is 49, and we need the fourth time, correct? Do we agree with that statement? We need the fourth time it reaches 49? Because he went on for 4 rotations, right? I would have wanted to get off a long time earlier, 96 minutes. Like, this is insane. I hate Ferris wheels. This is like possibly the worst thing that could happen to me. That and an airplane not doing well. Those are my options. Okay. I also don't like airplanes. I don't like heights, as you can tell. It's a thing. All right. So y2 is 49. If you ever want information from me, there's 2 ways you can get it. 1, you can take a fork and a knife and rub them together. I will tell you anything. I actually cringe. Ooh, I'm getting goosebumps talking about it. Oh, I'm getting goosebumps. Yeah, it's not cool. And then the other thing that also bothers me is taking a fork, putting it on my head. Oh,
I do that all the time.
I actually like, please use your lips. I can't. It makes me crazy.
Why do people do that? That's like this, like that.
No, that's even worse. I mean, like when you eat. Oh, yep, it's really bad. Goosebumps again. And then heights of any sort. You just like tell me to like get on the top of a granary and look inside of it to see if there's actually wheat. Is like my dad be like, just climb up there, see if the bin is full. No, how about you do it?
I do
Nothing.
jump on the glass at the county tower.
Can't do that. Wouldn't be able to. Yeah. I know. I can like when I'm like I have to like talk to myself. Like when I'm on the elevator at like 4 years old, I'm like, you will be okay. It is just going to the top. Your ears are popping. Oh my goodness, it's really high. We're getting.
It's like, oh, what if the tower just like? I'm not.
Yeah.
I'm the person that localizes when everyone's like off class. Oh, what is this break? You're like,
Yeah. Who are you? Trying to ruin people's lives? Okay, that's what you are. Okay, not note to self. Not going off you.
Who are like, well, they just won't step on it. Like, no, it's still the top. I was there.
So we have to remember that it's the 4th time. So people count this one as 1. You can't count this one as 1. It's the 4th time you went around, correct? So technically, I guess you say it's the 5th. So this would be him doing 1 full rotation, boom. And this would be him doing 2 full rotations. And him doing 3 full rotations. I just thought about the fork thing again. And then, so this is, 1 full rotation, 2 full rotations, 3 full rotations, 4, boom. We need to find here, right? So second trace 5. You could do this way. Oh my gosh. This is a terrible way, just so you know. Do this way. And we could have put in 49 and found out where they intersected. Boom, boom, boom. 148. Or what could we have just found? Starts with an M. Rhymes with minimum. We could have just found the minimum. So let's clear this. We could have went second trace minimum. Oh, yay. Oh, look at how much faster this is going. It's crazy. So left bound of it, enter. Right bound of it, enter, enter. 148, same answer, correct? Because we're trying to find the time it reaches that minimum.
Yeah, still.
So 148 minutes, done. Are we done? 148 minutes on a Ferris wheel, guys. That just sounds awful.
Isn't that just the thing that goes with this?
Isn't that just the thing? A Ferris wheel? Yes.
Oh, I was kind of a rock, like the, yeah.
That also is terrifying. Do you know how in Disneyland there's a Incredicoaster?
Oh, yeah.
My whole family goes on it, but me. Like, I will take pictures. Kind of thing.
I'll watch from over here.
I'll watch over here. I got you. I'll hold your bag. Like, I have so many options. Okay. Jordy got off the ride. At 148 minutes. There are there are 3 rides I don't want to do at Disneyland. One is the Incredicoaster, never got on it, never will. 2, I did do the Ferris wheel, the Mickey Mouse Ferris wheel. Does anyone understand what I'm saying? It is not a normal Ferris wheel. There is a normal Ferris wheel spot. We didn't know that there was. It looks so gentle. So there's the Mickey Mouse Ferris wheel.